Good morning, guys. Welcome to the webinar on technology of the future, that is blockchain. I am super excited to have you all here. Excited about all the amazing conversation that we are going today. Thank you for joining us for today's webinar. My name is Smith Sakriya. I am a lead of blockchain department along with Marcy Pandya. And if you have any question during the webinar, please type them into the chat box. I will bring them up during the webinar if necessary. Or we also have time for the question at the end. So I had like to introduce our today's speaker. Today we have Dharamveer C. Jadeja as a speaker, and he will be taking us through the journey of blockchain. He has a defining experience in blockchain space. He has worked with almost all the pioneers in DeFi space like OpenSea, Sartix, OneEach, Uniswap, Unstoppable Domain, MoonPage, and many more. He has also written an article to improve existing system with blockchain and to take blockchain in different manner, not just as a cryptocurrency. He is currently working at XP as a blockchain developer, and XP is a cryptocurrency exchange firm that aims to be an ecosystem where one can get the freedom to do everything with what one can imagine with a crypto. So now, without further delay, I would like to welcome Mr. Dharamveer C. Jadeja. Over to you, sir.
Thank you, Smith. Thank you for a beautiful introduction. Hello, guys. Good morning. Can I get a good morning back?
Good morning.
Good morning, Dharam.
Hi, good morning.
All right.
Good morning, Dharam.
We have few participants which are active. I want all good mornings. How many participants do we have? We have 62 participants.
Good morning.
Wake up, guys.
Good morning.
Good morning.
Morning, sir.
All right.
Good morning.
So, Smith, can I share the screen now?
Yes.
Okay. Give me 1 second. Entire screen. Okay. Is my screen visible to all?
Yeah.
Yep.
Yes.
Yes, sir.
Perfect, guys.
Yes. Yes.
So we'll start with a beautiful quote, which is innovation is the habit of an outcome. It's not a random act, right? We are looking to a blockchain, a technology which came into the picture in 2009, but ruined out the whole financial market right now. As we can see, every technology, every industry, everybody is talking about crypto right now. Is everybody talking about you say blockchain right now? So it's not a random act, right? It's an outcome of an habit, right? So innovation starts from just having that thing in your day-to-day life, nothing else, right? All right, so how many of you agree on this statement? Blockchain equals Bitcoin. How many of you agree? How can I view the chat? Oh, from here. Okay. Okay, I can. Okay, I see raise hands. Guys, how many of you agree? How many of you agree? Okay, 3 people agreed. Anyone else agree? Okay, we have Ravi who is agreeing. Ayush, we have Ayush agreeing on that statement. Anyone else, guys? All right, so how many of you disagree on this statement? Okay, now we have a big hands. Yeah. Nice. Okay, majority, we want majority, guys. This is like 20% of our audience right now. Okay, perfect. Let's see what is the answer. So yeah, it is not equals to Bitcoin. So blockchain is not same as Bitcoin. So this is one of the basics and misconceptions in the mind of newbies where they understand that blockchain is equals to Bitcoin, right? Yeah, Satoshi Nakamoto in 2009 wrote the same paper which says that this is the technology, right? This is the whole blockchain technology and he gave it a name as Bitcoin, right? But we can separate out that thing. How we can separate out, we'll look in the later part. But blockchain is not Bitcoin, but it's the technology behind Bitcoin, right? So any of the technology, they have some of the use cases, right? So it is same where we can have Bitcoin. We cannot have Bitcoin without blockchain, but we can have blockchain without Bitcoin. Okay. If that's not if blockchain is not Bitcoin, then what it is? Let's take a simple book analogy, right? A simple thing. I have one book, right? This is not a normal book. This is like a magic book where I write all my budgeting and credit and debit and stuff, right? Now, I just went out this morning. I brought milk, which cost me around 25 rupees. So I have wrote down that 25 rupees milk. Now, what I did is it was a transaction, right? I did a transaction that I gave the shopkeeper 25 rupees and he gave me a pack of milk. Now let's say if that's a transaction, then can we say that the whole page of transactions can be a block? Let's imagine on that. Can be a block. And collections of blocks can make a whole blockchain, right? This was a book analogy. Now we all are computer science students, so let's take it in our language. How many of you know what is linked list? Okay, we have. Okay, we have some people who know what is linked list. Let's see. In linked list, what we have is we have a node. That node runs on and it's stored at one address, memory address, and it has some data. Now, if I want to add a new data, what I'll do is I will create another node, right? and put the data in. Right now that will be on 2001, maybe, who knows, right? So if that's on 2001, now if we want to link this to node, what we just do is we just add the next node address, right? Same for the third node. If you want to add, it's on the different address. If you want to link it to the linked list, we just copy it to the next address, and that way we all goes into a link. Now, how blockchain is similar to linked list? Let's see. Now I want something from participants. What common do you see between blockchain and linked list in the diagram? Anyone can speak up?
Stores the address of the other block. The block
Stores
before.
the address of other block and the previous one.
Like A1B and A1B are both in both of the blocks.
Okay.
C5D are both.
Shows the S code of the previous block.
Same as doubly linked list.
Now, good observation, guys. Anyone else want to try?
Also, it has its unique code also.
It has something unique. Yeah, good observation, guys. All right, let's see what is common between those. So in linked list, what we have is we have the address of the next node, right? But in blockchain, what we see, if we look linked list, it's in this directional. So from left to right directional, the chain goes in this direction. Now in blockchain, what happens is you have you say, what do you say? Let's call it as a block, right? Then we'll go in depth what is it, right? But as of now, let's take it as a block, something, or you say a transaction, the 20 rupees one, right? So the middle portion, the middle line is something which we need to notice, right? The lower line, it is a hash. What is hash? As of now, you can just remember it as a random number or a random string. Okay. Now, if we forget this, right? If we forget this, what is common in this is they have a relation of the next node, right? Now, so what happens is if this is a transaction, right? It has a hash. That means there is something random. Okay, there is some random string which is generated. Now, let's say a new transaction came in. Now, what the new transaction will do? It will also have some random strings. So the random string is generated. Now, how do we link both the things? To link both the things, we will capture the previous hash from here and put it over here. Right? That will make the chain. Right? Now the third transaction came in. We have some random strings generated, right? But we need to link it to the previous block. How do we do that? With capturing that random string and put it in our transaction, right? Before we deep dive, do you guys got a general scenario what it is, why it is matching with linked list? Anyone can say, or do you guys have any doubts in this?
Hello.
Yeah, please carry on.
You said hash is generated. So is it generated randomly or like randomly something or some specified thing?
A hash?
Yes, hash.
We'll cover hash in later slides. I'll talk more on to hash, but just for a brief analogy, let's take it as a random string. But it's technically it's not a random string. I'll cover that part.
Okay, thank you.
Okay. Now let's dive into blockchain. So we can understand this diagram as this is the 25 rupees transaction which I did. This is the whole page of the transactions, and this is the whole book of the transaction. Okay, let's just remember it in this manner. Now I'll take a use a small example over here. Let's say there are two peoples in the transaction involved, that is Mr. Pink and Mr. Green. Just for an ease, let's say Mukesh Ambani and me. Right now we both want to do a transaction. Now Mukesh Ambani will give me 2 Geo coins and I will pay him $100. Okay, so we both agreed on that and we signed that. Right, in a traditional system, what we do, we have that stamp paper and we sign it that yeah, I give 2 coins to this person and I will receive this particular amount from this person, right? So let's take that simple example. Now let's say we did a transaction, right? We signed it with our digital signature. Now what happens is that block or the transaction, okay, this transaction, which was what, me and Mukesh Ambani doing a transaction for GeoCoin against $100, right? So this transaction is went through the network. Why went through the network, you ask? Because maybe I can influence one person, maybe I can influence 2%, or maybe Mukesh Ambani can influence hundreds of people into dealing in a false transaction where Mukesh Ambani can say that no, DJ has only given me $50 and I owe him $50, right? At that time, that's a false thing. So how about we have 63 people on the call, right? And what if me and Mukesh Ambani do the transaction right now and give it to all 63 people in the room that yeah, me and Mukesh did the transaction, right? So Mukesh can influence 1, 2, 3, 100, maybe, right? 50, anything, but he cannot influence all of them because they are pseudo. Mukesh Ambani doesn't know anyone over here, right? So this is why the transaction is populated throughout the network so that all has the copy of that particular transaction, and they can say that yeah, no, that's a false transaction, you are doing false thing, right? That's not possible. DJ give you $100 and you gave him 2 coins. That was a valid transaction. Now you are saying that DJ only gave me $50 and I owe him $50. That's a false transaction. So that's how I have a proof, or anyone in the network have a proof that their particular transaction is being populated throughout the network, and no one can just influence 4 or 5 people and say, yeah, that's a false transaction. Now, once the transaction is populated throughout the network, let's club it, right? So the book one, right? Now I did a few transactions, right? I show you that, okay, this is the Mukesh Ambani's transaction. And this is the thing. Now I have a bunch of transaction being done. So what I'll say is it's a page of transaction, but in blockchain we say it as a block of transactions which has multiple transactions. Now that has some random string associated with it. You remember some hash, right? Over here as well, that is there's a random hash, right? Now what happens is in this diagram we saw that there is a random string, and if the next one is coming in, there is a previous transaction hash been attached to this. Okay. This what happens over here as well, that it's let's take it as a Lego example where the particular block is a Lego block. You have the negative points, and in the front you have some positive points which can attach the Lego, right? So that negative and positive points are nothing but your hash. For us, it's a random string. Now, if the transaction is run, the block is being done, right? We have the random string, right? And the Lego is attached. Why Lego attaches? Because the previous hash and my current block's previous hash are matching, right? Now, let's understand, okay, this was, okay, it's a positive flow that, yeah, the transaction was done, it was populated, and there was some random hash generated, which keep it as a security that it is a random, right? And we attach it as a Lego. Now let's understand why it is difficult to change. Why Mukesh Ambani cannot change the particular transaction. All right. So we'll understand what is hash now. So hash is nothing but a mathematical function that takes the digital information and generates a string of characters and numbers. Right. And there are three important characteristics of that thing. First characteristic. No matter what the size of original file data is, it will generate the hash in the same length. Now, same length in the sense, if how many of you know what is SHA, secure hashing algorithm?
SHA-256, SHA 256, one of the algorithms.
Yeah, algorithm. Okay, SHA. You know SHA. Any hashing algorithm apart from that? SHA.
ROT 13. Cipher, that Caesar one.
Anyone else in the chat? Hello.
MD5. MD5.
MD5.
SHA-512. NTFS. NTLN.
Good. Hello guys. Are you guys sleeping? Hello. Give me a hello back.
Hello.
Hello.
Hello, sir.
Hello.
All right. We have active participants. That's what I wanted to check.
Hello.
All right. So yeah, this all are hashing algorithms.
Am I audible?
Yeah, you're audible. So the people who know what is hash, right? They also know that no matter what the size is, it will give it is the same length. So if we talk about SHA 256, it will always give us data back in 256 bytes, right? So this is one example, right? So This was the tweet done by Jack, who is the CEO of Twitter, back in the days when he was making Twitter. So he tweeted just setting up my Twitter. Right. So if we hash it off, right, that text just setting up my Twitter, what it will give? It will give me this thing, which is a hash. Right. And now we know hash is nothing but a mathematical operation which will be done on the data, and it will give us some alphanumeric text. Right. And the first characteristic is that no matter what the data is, it will give you the same length of output. This is the one of the great book, which is War and Peace. It is almost about 1,000 pages, right? Now, if we hash that book as well, it will only give us the data in 256 if we are working with SHA 256. Okay, so first characteristic, we got it that no matter what the data is, no matter how big the data is, it will give us the output in the same length every time. Second characteristic is, so if you, so this, if this is a book, right? If I erase a comma, or if I just add a space, or if I alter any of the word, the hash drastically changes. Right? So let's take it as an example. I'm sending one link in the chat. Can everyone open that? Just give me a heads up when you are on this link.
Yes, it opened.
Okay. Okay. Is everyone there on this link?
Yes.
Yes, sir.
Yes.
Okay, perfect. Now let's type something. Let's say chapter. Right. So let's copy this. Right. So I'll put that down so that we can check the first characteristics, whether or not our first characteristics is fulfilled. Now what I'll do is I will take the whole chat. Can I copy all the chats? Yeah, I can copy the chat, the whole chat. Copied the whole chat of our current session. I paste it over there. Right. So this is the whole chat, and let's copy this back and put it in our experimental pad. So if you guys can see, this is the same length of data, right? So no matter the first characteristic says that no matter how big the data is, it will give you the output in the same length, no matter what. Right? Is everyone with me?
Yes.
Yes, sir.
Yes.
Yes, sir.
Yes.
Okay. Okay. Can anyone give me a big text in the chat, like Laura Mipsum? Let me do that. Let's copy this whole thing. This is 5 paragraph text. Paste it over there, right? This is the 5-paragraph text. Copy this, I'll copy this. And voila, we get the same length of data back. Are you with me, guys? Any doubts up till now?
No.
No, sir.
All right. Everyone is getting the sense of the first characteristic?
Yes.
Okay.
Hello, sir.
Yeah.
Sir, can you please tell how did you run the program? Like what you did after copying the thing?
So I just copied and I pasted. I just copied from lorem ipsum. Let's do it again. Right. I did nothing. I just copied this and I pasted. So the new hash is generated. That's it.
Okay.
All right. So we are all good on our first characteristics, right? Okay.
Yes.
Now
Yes.
let's see our second characteristics. So I'll clear my experimental pad now. I'll copy this. This is the big text. Okay. Now, anyone can suggest to me what should I remove from this, or should I update from this? Can anyone say? What should I update?
Let's just remove a comma or a like special character, something very nominal.
Remove the
Okay.
question mark and make exclamation mark.
Okay, let's remove the question mark and let's do it in an exclamation. All right, we did this. We just did a single character change. Now let's compare our hash. Is it the same or not? I mean, how can exclamation change the whole thing, right? We have a whole different hash. All right. We just changed a text, which is a big text, like a 5-paragraph text. We just changed the question mark to exclamation mark, and the hash dramatically changes this. Right? All good with our second characteristics, guys?
Yes.
Are we getting it?
Yes.
Yes, sir.
Yes.
Yeah.
Yeah,
Okay.
and I think there are two people who have raised their hands. So, do you folks have any questions? Narmatha and Brahmadev.
No.
If you have questions, then you can ask, and if not, then you can just unraise your hand.
Yes, I wish.
Okay, we can move forward.
Excuse me, sir.
Yeah, go ahead.
Sir, I've typed the question in the chat. Sir, if we put up the question mark again, will we get the previous hash back?
Nice question. Nice observation. Let's do it. Let's put the question mark again. Is it the same? This is the new one. This is old. And this is new old. Let's remove the new one. It is giving the same hash, right?
Yes.
So no matter in what point in time. Yes.
So if we use capital instead of second ABCD, so hash will be changed.
Let's try. What do we want to do in capitalize? Should we do this? Where? In capital?
Yeah. Yeah.
Where we just wrote the whole where in just capital. Let's see if the data changes or not. Yes, it changes. It changes from our old. It is different from our old. It is also different from our new one. Right? So manipulating any data, even a single exclamation can cause a drastic change in the hash. Right? Good with
Yes.
second characteristics? Any doubts on this?
Sir,
Yeah.
is it possible to use the hash to retrieve back the data?
Let's try it. I'll give you a hash. I already have that. Right. This is one of my pre-populated hash. I am putting it in the chat. Can anyone give me the data of this? Can anyone tell me what is the data of this hash?
No, sir, it is generating another hash.
What if I tell you?
The hashing key will be unique, right?
Yes, the hash will hashing key in hash. I guess the hashing key for 256 is always there, right? So hash key is not an issue for any of us. What if I say you the hash is nothing but your institute's name? Can anyone compare? Is it the same or not?
Oh, yes, it is.
It is same. Okay. So now that's our third characteristics, which is hash are unidirectional. So you can't get the data back from hash. Right?
Yes.
Perfect. Now we learned about hash. Now if we jump back to this, now does it make sense to you guys that this is a data we hashed and we got some we run a 256 or any algorithm on this, we get this random string, right? New block came in or new transaction came in, we hashed it, and this is the hash, right? Now we also saw that if the text or any of the data is same, the hash is also the same, right? So that means hash are always unique, right? If hash are always unique, can we use it as a reference? Because it will always point to one transaction only, right? So in that way, we took this and put it over here, right? New transaction came in, we did the hash, we found this thing, but if we want to link it, so what we just did is we just copied this previous hash and put it over here, right? Now is this diagram making sense to you guys?
Yes.
Yes.
Okay, now can anyone tell me, this is a unbreakable thing, or you say unstoppable thing, where you have n numbers of transaction being attached to the blockchain and you can copy this, and if the new transaction came in, you just copied this, put it in the what do you say, the previous hash section, and you move on from there. So you can traverse back, right? I can traverse from JKI to ABC with the help of previous hash. Yes or no, guys?
Yes.
Okay, we can traverse back. We got yes. Hello, can I get a
No,
hello
sir.
back?
How it can go from JK to ABC? It doesn't have the address of behind.
Yes, good observation. Now what we can do is, so from JKL, I need to go to ABC. So what I'll do is, so I know this is the previous hash block, previous block's hash, right? So from here I can jump to the previous block, right? From that, I know the mechanism that it will be a unique and it will give me the previous blocks hash, right? So I can just check that which is the previous block from the previous block hash, and I can jump onto that. Again, I'm here. I want to go to the previous one, right? I look at this. I look at this. I jump over here. Now from JKI to ABC, I just took the help of a hash and the previous hash. Now getting it?
Yes, sir.
Okay. Now, can anyone tell me that if I can traverse back, and back, how can we determine the starting of the blockchain?
By seeing a new hash.
Starting. So
zero
start
zero
from.
zero. Yes.
Okay. One observation which is 000. Okay. And can anyone else try? How can I determine the start of blockchain?
Starting block does not have hash of previous block.
Okay.
It has a specific hash that says it is the starting block.
Okay. Anyone else want to try? Anyone else want to try, guys? How can I determine the previous hash? How can I determine the first block of the blockchain, the starting of the blockchain? Okay. Yes, your observation is right. It has a specific hash, right, which is 000. Right? If the previous hash of any block is 0000000, that means that is the first block of blockchain, and that is known as Genesis block. Are you getting it?
Yes.
Yes.
Now this might also be clear that me and Mukesh Ambani did a transaction, right? You all validated it that yeah, me and Mukesh did the transaction. The hash is also generated for a particular block, right? And the previous, I took the previous hash, right, and I attach it to the blockchain. So that way, if I add a new block over here, the hash may be AAA. And if I want to attach it with the blockchain, I'll simply just copy this BBB and paste it in the section where I'll put the previous hash. Okay. So this way it also attaches with the blockchain. Right, the newly added block. We looked on to hash. Right. We also saw that third characteristics. Now, why it is very difficult to change anything in the blockchain? So if you remember, we just did from exclamation, sorry, from question mark to exclamation, and the hash drastically changes. Right? So if me now going in, like Mr. Green is me, I go there and I say that, okay, Mukesh Ambani just give me 1 token only and I owe him 1 token. But the mechanism stays the same, right? If mechanism stays the same, my one change in the data can drastically change the whole hash, right? And if a block hash is different, the whole chain from that breaks off. Why? Because everything is dependent on the previous block, right? So, and if I change any of them, it breaks the whole sequence because now the hash is different. If I want to jump back, how can I jump back? Right? And all of your copies of the whole book, right, will be different because if I change, let's say I add the last block and I try to manipulate that last one only because nothing will break because there is no tailing blocks in it, right? So I can manipulate the last block. But now you guys, the audience who are having the copy of the whole blockchain can say to me that no, DJ, you are wrong, right? In our ledger or in our collection of data, you guys did a transaction, you gave him $100 and Mukesh gave you two tokens, that's for sure. So there are 2 ways to validate the false transaction, right? The first one is the blockchain itself and the second one is the decentralization of data. Right? There is no central entity where I can just update the data and say that, yeah, okay, I owe 1 token to Mukesh, or can Mukesh say me that I owe him $50, right? Now let's take this example. Let's look at the whole blockchain in more sensible format. So previous hash is 0. This means this is a Genesis block. Who agrees on this?
Yes.
Okay. Dharmata agrees on this.
Yes.
Anyone else?
Agreed.
Okay. All right. Let's add a new block. Can anyone suggest? Let's take a name of Jay. Right. Let's add it to the blockchain. Jay Gohil. Right. Now we add it to the blockchain. Right. So this is the previous hash. Right. This was the hash being generated. Right. This was the data. And this is the previous hash. Right. Who else? Who else? So basically our example is that this is the list of nominees for new president of India. Okay. Who else, guys? Who else? Let's take another example. One of my good colleague, Jay Patel. Let's add it. Who else? Who else want to participate, guys? Anyone else want to participate in this?
Yeah, I think they are raising their hands, I guess. Yeah.
Oh, okay, okay. They are raising their hands. Okay, okay. Let's do that. I can't just copy the name.
Yeah, I think you will need to open MS Teams in web to do that. Otherwise, you'll just have to type it manually.
No issues. I'll type it.
Yeah.
I'll not write the full name. Dave. I see Dave. I see Daniel. It's Dave, right? Who else? Who else? I'm sorry guys if I pronounce your name wrong. Sorry guys. I'm very bad at pronouncing names. Oh, Sunena also okay. Okay, that's it, guys. That's it. Now let's say Jay Gohil knows that Dave is going to win this, right? Win this election. So what he does is he changes this from Dave to, let's say, me, because I'm very bad at politics, right? So he just changed it. But when Jay did this, you can see the whole blockchain is now being drastically changed. Why? Because the previous hash doesn't make sense to them. Right? In the previous, let's put the Dave again. Right? Now the hash of this is 0006, right? So all the things are falling in that manner only. Right? Now Jay change it to DJ. This changes the hash and it invalidates the whole thing. Now there is one method Jay can do to validate all this transaction. It is recalculating the whole hash, right? So calculating the hash and updating the blockchain, right? This way he did this. Now he did for the next block and the next block and the next block and the next block up till the last block, right?
What are those numbers coming up? 4729361.
These are used mnemonics. Sorry, nouns, not mnemonics, nouns. These are nouns. This makes this block as a unique block, right? Apart from just having the hash, they also have something called nouns, right? So everybody got it, how it is difficult to change. And for mining, what I just did is, so let's change it back. So what I just did is I mined those transactions. Now for mining, in different blockchains, there are different consensus algorithm, right? We'll not go into depth of consensus because it's a long topic altogether. In Bitcoin blockchain, we have proof of work, right? In Ethereum, we also have proof of work, but now they are shifting to proof of stake. So in proof of work, you need to give proof of you mined the transaction, right? So if we understand proof of work in a simple example, this was the hash which I gave in the chat, right? And no one can give me the data back, right? Because we know that the characteristics of hashes, it is irreversible. Now, what if I say that if you want to submit the proof, you need to give me the data which was in the first place and tell me that it is matching to the current hash, which has been broadcasted throughout the network. Right? So what miner needs to do or what the validator needs to do, they need to recreate the whole transaction. That means guessing that what is the data for this, right? So if we just guess, right, the SHA-256 will take years to calculate what was the original data in a normal machine. If you take you say high profile or high configuration machines, it can maybe take few days or few hours, even few minutes in a high configuration. But think you need to give the proof of each block and each following block. So you gave the proof of this block, then you give the proof of this block, then you gave the block proof of this block, then you gave the proof of this block, right? And as of today, Bitcoin blockchain is having more than 700,000 blocks attached in it. So imagine the power and imagine the computation energy which requires to change the whole data. Right now, enough on the studies. Let's take if the thing which we saw over here, let's say if I change a small data, right, the block or the whole chain following that drastically changes and you say it destroys in itself. So this reminds to me of a GEMS ad. Let's look at it. Right, this is me and me updating the block, right, with the new data, right, has changed and I'm very happy, but I don't know what are the consequences of this. Now you got it, guys. If I change a single data in it, it will drastically destroy the whole blockchain. All right, now we'll have a 5 minutes Q&A session, right, in order to answer some of the questions if anyone has, and then we'll move forward with a few slides. All right, guys, let's take a 2 minutes break, right? And if in between, if you guys have question, you can shoot me out on the chat. I'll answer it.
Hello, sir. I have a doubt.
Yeah.
Sir, like you manipulated the data of Dev, like from Dev to DJ. So how will the other people know that you have changed and not someone else have changed it, the data?
Yes. So it comes in the next slide that there is no update operation in blockchain. So there are only two operations, which is read and create, right? So in order to update this, what I need to do is I need to recreate the transaction, right? Now, if the transaction is recreated, that means there will be some signature which will go in, right? So from that,
yes,
I can identify that this was the only person who changed the transaction. And one thing which I forgot to tell you, one thing, let me do that. So let's say now again I change it to Dev, right? Now you all have the copy of the blockchain. Am I correct on that? You all have the copy that, yeah, these are the list of nominees of next president of India, right?
Yes, sir.
Now, while I was calculating the whole blockchain again, right, someone of you noticed it and check that my records of data, right, are not matching with your records of data. All right, so we understand two things, right? That if I change the hash drastically, if I change the data, the hash changes drastically. That's one thing. right? And for that, I need to recreate the whole blockchain. I mean, I need to remine the whole thing. But second thing, which is decentralization of data. Now, if you compare your data with my data, it will be changed. Right? Just give me 1 second. Sorry, guys. Yeah. So, okay, what is this? Okay, never mind. So, if you check your copy of the data, right, you will notice that there is a difference while I was doing this, right? Because this is the whole blockchain which I need to recreate, right? I need to remine it. So at that time you noticed, and the whole network noticed it, that yeah, this is not something which is considerable, because now what I need to do is, if I recreate this whole blockchain, I need to give the data to all of you that yeah, this is the new updated thing. But that is not possible, right? So what you'll do, the network will kick me off, that yeah, you are doing miscellaneous things, you get out from the network, right? So in this way, the blockchain stays immutable.
Sir, I have also one more doubt.
Yeah.
That sir, you said that you and Mukesh Ambaran did the deal, and in the network, everyone knows that you did a deal of $100 with you. So, like, then how will the privacy will be maintained? Like, if you don't want to reveal the transaction, then how the privacy will be maintained?
Nice question. So this brings down two types of blockchain. Right. So there are mainly two types, but there are three types of blockchain. The first is public, private, and consortium. Right. Now for public blockchain, the whole data is being with the public. Right. In private, you have certain level of authorities who maintain the data, and in consortium you have group of people, or you have group of organization which can allow or deny the view and all the things of the transaction, right? So it comes down to the type of blockchain which you are using for your transaction, right? So if me and Mukesh do the transaction on public blockchain, everyone knows it. But if me and Mukesh do the transaction on private blockchain, none of you know that. And still the consensus stays the same, because the viewing of the data is being hidden, but the consensus or the record keeping stays the same.
Yes, sir. Yes.
Does it make sense to you?
Yes,
so,
sir.
Prayag, yeah. Okay. Perfect, guys. Any more doubts?
Yes, sir.
Yes, sir.
Sir, like you told that every transaction is maintained in a ledger, right? Which everybody has on the node, on the network. So in case someday a new node joins the network, so does that node have to download all the data that has been transacted till date?
Yes. So that is known as full sync node, right? So in order to be participated in the whole network, you need to first have all the records, right? Because if you don't have all the records, how will you identify if there's a miscellaneous thing going on or not, right? So if you join, let's say you guys are in college, right? So let's take an example of college. So if you join your semester late, let's say in first semester you joined late, so you need to cover the 4 chapters which were been already delivered to the students in order to sync up, right? Because after all, at the end you will fail in exam if you don't study that 4 chapters. So in order to join that particular class or join that semester, you also need to have that 4 chapters which have been delivered in order to be in sync with what is running on. Let's say if the 5th chapter comes in, right? If you don't have the idea of what the 4th chapter was, you may or may not have an idea of what the professor is talking about, right? So in order to be in that class, you first need to study that 4 chapters, and then you can easily understand what the professor is talking about. Does it make sense to you,
Yes.
Daniel?
Yes.
Okay.
Yeah, I have a doubt as well.
Yeah.
So, for example, I'm an author and I have want to publish a work, and you showed one example that for a transaction the hash, if I change one character, for example, uh, so that doesn't make any change in the value of the work that has been created. uh, just one character, the knowledge it will impart or something like that. But here the entire hash is changing. So how do we make sense to such a transaction, because only one character will not change the imparted value of the work or anything like that.
So basically what you're trying to ask is how can we make the things which is scalable in terms of mistakes, right?
Yes.
So for this, I would like to tell you that firstly, the data doesn't make sense to the blockchain, right? What is the data? It can be anything, me, Mukesh doing the transaction, or me, someone else doing the transaction, or maybe I even publish a book, right? So what I do is I first did a transaction with the whole book, right? But I forgot to mention you say credits, right?
Yeah.
So at that time, now what I need to do is I can't update that thing. But what I can do is I can do another transaction, right? With the updated credits and updated book, and tell the audience that this is the new book.
Yeah, right. But my question pointed to that if somebody else, for example, changes the data, so how will the copyright work then? If I have produced the work and I'm publishing it, and someone else just changes one character, and the transaction can be made with another hash, so how does that work out then?
Okay. So copyright things. So over here, what you can do is you can attach the person's name. So let's say I'm the author, right? Now I was the author, I did the transaction, right? You know me, right? I published that book. Now, if I publish that book in the blockchain, what will happen is the transaction itself will say that me as the author did the transaction.
Yeah,
But
right. Sorry to
if
interrupt. Uh, I means in this part only. So this is like a Web3 thing, no? So, uh, you know that the author of the book is some person, but doesn't you cannot verify that that person is that is only through keys, no? So, how will you verify that a particular person is only doing it from anywhere in the world?
so that doesn't matter because your keys will remain unique. So blockchain is not about identifying person, but it is to identify the keys, right? If you have the same keys,
Yes.
right, and that's not something which you can have,
Okay.
right?
Yeah.
So at that point in time, if I have the key, right, I signed that transaction and the whole blockchain knows that, yeah, I did that transaction. But now you jump in, you copied that thing, right? The copied the whole content and you did another transaction, but the audience will not accept it. Why? Because they know that this is not something which the original author did.
Okay, right.
Right?
Yes. Thank you.
Perfect. Now let's jump into some of the differentiation. Right? What is the difference between blockchain and database? Because to me, up till now, it seems like it is similar to database, but let's look at what it is. Blockchain is decentralized because there is no central admin or in charge, right? You can do anything, whatever you want in the blockchain. You do a transaction, you mine a transaction, you verify a transaction, right? There is no central authority. But in database, you always have an admin, administrator, and stuff like that. Blockchain is permissionless because it can be accessed by anyone, right? But the database can't be. You need to have the access keys. You need to have you say username and password and whatnot in order to access the database. Blockchains are slow and databases are fast. Yes. Why? Because the transaction jumps in, someone mines it, it goes to all the miners or all the nodes to get a copy. So in that sense, the blockchain is slow and database is fast because it's centralized. One update can do anything. It has a history of records and the ownership of digital records, right? So I did the previous transaction with missing credits, right? The blockchain stores that as well. I did the new transaction with updated credits. Blockchain also stores it. So you can always have the history of all the records. But in database, you just put update query and that is done. In blockchain, we only have create and read operation. As I mentioned, you can only create, you cannot update or you can delete the previous block, right? Or any transaction in the block. So there are only two operations, which is create and read. In database, you have all CRUD operation, which is create, read, update and delete. What you do, whatever you want to do with the data, right? Now let's come down to use cases. So there are n numbers of use cases. Sky is the limit for use cases, right? But these are some of the use cases which I could found. All right, this covers not just the cryptocurrencies, but the overall blockchain itself, because blockchain is not just about cryptocurrency, right? You take blockchain in a different manner where it can be used for healthcare, it can be used for identification, it can be used for you say power grids, right? It can be used for medical data, it can be used for insurance data, it can be used for supply chain, it can be used for waste management, it can be used for journalism, it can be used for tourism, energy, anything, whatever you think can be a part of blockchain, right? So let's not limit the blockchain and in just cryptocurrency and you say all financial system. Blockchain itself is a technology which can make a whole new internet. So sky is the limit for the use cases, right? So think broadly, right? Not just in a cryptocurrency manner where you make some DeFi projects and do this thing and it is related to finance, but you can even do you can even think of having decentralized countries, right? Where you have you request for a passport, you get an approval, you being in that country with the visa system which is currently working, right? You can have that thing as well on the blockchain. You can have power sharing, you can have shared grids between the you say the across the globe, right? So blockchain is, I say it as a new internet, right? And I stealed this dialogue from my CTO Sailesh that blockchain is the new internet. Right. Let's look at some of the live use cases which are currently live. One of, as everyone's favorite, the use case of blockchain is Bitcoin. Right. It's a peer-to-peer network to send money. The second popular use case of blockchain is Ethereum, right? Which can also be used for you say transaction on peer-to-peer, but it also allows developers to develop decentralized applications on top of it. Let's talk more about Ethereum now. So as we all know, Ethereum is an open source you say framework which allows anyone to make their own logic on thing, right, and deploy it on the Ethereum network, and you don't need to worry about downtimes and third-party interfaces in order to run your contract, right? Let's look at smart contract. What is smart contract? We mentioned that there is something called smart contract which allows us to do that. In simple words, any logic can be written over the Ethereum blockchain and it's known as smart contract. Right? Anything, whatever you can imagine, right, can be written. So from what I think is anything which you say that me and Mukesh doing the transaction, there is a logic in between, right? That I need to pay $100 and Mukesh need to give me two tokens, right? A contract is, you say, simple, is a computer protocol, right, which verifies and enforces and negotiate the performance of the contract. So the logic which you have written needs to be work on its own, right? They need to verify that yeah, I gave some money, someone gave me a money, or I pay the rent and the rental needs to allow me to stay there on their home, right? So logic can be anything. Sky is the limit. Smart contract allows performance credible transaction without third party. So in that you don't need to have third party. You can do a credible transaction which can be used as a proof that yeah, we both did a transaction, neither me nor you disagreed on the transaction, right? So we can perform credible transaction on that. And on smart contract, obviously it's running on Ethereum. So Ethereum is in public blockchain, as you all know. So all the transactions are stored in public ledger, right? And the language for writing any of the smart contract on Ethereum blockchain is Solidity. You can also write it in Viper, but most popularly the smart contracts are written in Solidity only. Are you guys excited to see what Solidity looks like? Anyone?
Yes.
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 Right. So let's see. I'm sending this thing in chat. So this is the contract of Shiba. All right. Why I took this as an example, because I am hearing every day on the news channel, everyone is just talking about Shiba. So I thought just to make a fun of how the contract is, right? A simple contract which is just written in few lines of code has a credibility to come in news channel, though not in a sensible manner, but in maybe in you say what do you say, in a funny manner or sarcastic things, right? So this is the contract of an ERC20 token, right? So you can see some of the things, like you can see the total supply, you can check the balance, right? You can transfer anything to anyone, right? Any amount. Allowance is a different thing, right? Allowance, right? Mint, you can mint new things, you can burn as much as you want, right? And if you see, these are all just the logic, nothing else. If you want to make a new token, that's a piece of code, nothing else. No rocket science involved in it, right? It's just a logic. It's just a function call which gives you all the things. That's it. Right. Now let's see. We saw that there is some token and we saw that smart contracts are nothing but a piece of code or a piece of logic written on the Ethereum blockchain. Now let's see what smart contracts are capable of. Right. So as we saw, ERC20 or utility token, right? Anyone can make their own tokens on public blockchains, right? And it's also known as fungible token, right? You can share. I mean, you have a rational price associated with it. It's not that something, the token which you have, it's always the unique, right? NFTs, right? The one of the big craze right now, the digital art, or you say collectibles, anything, whatever you say, it's also just a piece of code, right? ERC 1155, which is a substitute of ERC20 and ERC 721, right? It has a combination function of both of them. Security tokens, this can be involved in the new future, where you have a hybrid token which has a document attached with it. Let's say if any company wants to release their shares, but in crypto, so what share is nothing but a document which says that I own certain percentage of that company. So they can make a security token and they can attach that particular document with that token, and boom, they are live on the blockchain, but in the traditional system as well, which is the shared system. And it is capable of implementing any business logic like staking, farming, marketplace, swap, etc, etc, etc. So these are the well-known terms which I have written, but as I said, if it is in logic, right, you can write it. If you can write it on your C or C++ or Java, JavaScript, anything, if you can write that logic in that particular language, you can also write those logic on smart contract, because smart contracts are nothing but logic. Okay, let's talk about this. The difference between coin and token. Right. Many of them have a misconception of what is coin and what is token. Even when I started, I was thinking that, yeah, these two are similar things only, right? They just gave a name differently. But if I give you a simple example of what coin and a token is, so the coin is a fuel in order to run any of the blockchain, and the token are the asset which is made on top of it, right? So if that's a Bitcoin blockchain, right, so you need to have Bitcoin in order to run that blockchain, right? You need to pay some fees. So coins are fuel for any of the blockchain, and tokens are assets which are made on top of blockchain. Okay, making sense, guys? Hello, can I get a hello back?
Yes.
Yes.
Just two. We have six. How many do we have? We have 46 participants. Can I get a hello back?
Hello, hello.
Hello.
Hello,
Hello.
hello. Hello.
Hello.
No.
Okay. What is wallets? I guess we can. Let's not get into this wallets because we have lack of time, and let's do a new thing. Let's make our own blockchain. All right, guys, any doubts in Ethereum and smart
No.
contract, Ethereum, anything?
I have doubt.
Yeah, please carry on.
Yes, like last week I was studying about Ethereum and how people developers make dApps on that. But for whatever we do, we need to pay some gas fees that for the transaction that they carry out. Then why would some developer wish to make some project on that network that charges him large fees? I mean, he can create his own network and do the stuff, same stuff.
So over there comes a part of trust. Why people are trusting Ethereum? Because there are billions of funds which are being logged in Ethereum network, right? And Ethereum is running since 2012. So it's like couple of years now. So it is running up and running each and every time. So the people who are coming in, right? The developer is developing the application, right? So the developer also is secured that my application is up and running each and every time. Second is all the participants or all the users who are coming in, they might be investing their time, they might be investing their money. So they are also secured that, yeah, my funds are secured on the Ethereum blockchain and not some, you say, a new blockchain which comes in that can be a scam. Right. And for gas, there are different blockchains like layer 2 scaling solutions which we have. So in those layer 2 scaling solutions, the gas fees can be reduced. Maybe if you study about Binance Smart Chain or if you study about Polygon.
Matic. Yes.
Right. So that kind of you can reduce the gas fees to your users. There is a second method as well, which says native meta transaction or meta transaction, where your user is not having will not pay the gas, but you as a developer will pay the gas. But that's a separate thing. You can study on to it, what it is, meta transaction, native meta transaction, and stuff like that. All right, guys, are you all over here on this link? You click on this button, right? Whenever you get this, you click on the stop button. Now I'll make a Genesis block over here. This is testing for PDEU. I have submitted my entry. We need 4 more entries to create block. All right, guys, let's join this link which I sent. Okay, Parth came in. Guys, let's quickly join this link.
Sir, I joined, but what to do next?
Yeah, so you click on this play button, right? You enter your name, you enter your email, and you enter whatever the message you want. All right. So yeah, we have 4 participants now, right? And this is how we create the whole blockchain, right? So this is our Genesis block, right? This is our new block, which has my transaction, Parth's transaction, Ahmed's transaction, and Smith's transaction in it. Right? We have a new block, right, which has Amu's transaction, my next transaction, Joy's transaction, Ayush's transaction, Hate's transaction, and the blockchain goes on and on and on and on and on. Now, what if, guys, I change this. So if you have noticed, some of you are having the validation request, right? So if I change, let's say this is for testing for PDEU, instead of EU, I write it PDPU. I request for validation. That goes to someone randomly. It's a pseudo random algorithm, right? It went to this person and okay, I got a new transaction to validate from Smith, right? I'll perform the transaction and it went on. Why? Because this was a new fresh transaction. Smith, can you try to update it from this receipt? Can anyone try that? Can anyone? So over here you have receipt, right? So in that receipt you can update the data which you kept in the first place. Can anyone try to enter it? So there was one invalid transaction.
I did try to change it.
Okay, there was a second invalid transaction. But one thing which is keeping me in notice is I get the whole ledger. There are 6 nodes in the particular network. And I get the record of all the transactions, and not just me. You all get the copy of that transaction, right? So whenever a new block comes in, the validation request goes to some random people to validate it. If the validation is true, the blocks get added to the blockchain, right? This one, the Salish tried to update the transaction, but it didn't went in because it was a false transaction. Right? Gaurav did try to change the things, but it also didn't went. I also got another notification which says, "Hi DJ, hi Smith." Right, Smith. Okay, perform validation. Right. So guys, this is how simple blockchain is. You can participate, you can mine, you can enter any data. And this is how the whole mechanism works. Right? So if I reiterate on the things which we learned today, I do the transaction from here, right? It gets populated throughout the network, right? When there are collections of data, which is in our case over here, we have 4 records of collection. So if there are 4 records, that makes 1 block, right? So 4 transactions make a block in our sense. So over here it is there, right? We got the hash and the previous hash, right? The previous hash. This is the Merkle, right? So the thing which connects this two is the previous hash of this. We learned about if we try to manipulate it, the hash changes. We saw in this example as well as we see in this example as well. If someone tries to update the data, the hash changes and the whole chain breaks it off. Right? We talked about hash. We talked about the example where if I try to manipulate the data, the hash breaks it off. We saw this James example in this thing, right? If I try to just update any of the data, it just breaks the whole chain. We talked about difference. We talked about use cases, and we talked about some of the live use cases. There are many more, but I've just kept 2 for this particular presentation. We talked about smart contract. We saw CBAS contract, which is nothing but a logic, nothing else. We talked about capabilities of smart contract, what smart contract are capable of, ERC 2721, which is NFT, hybrid tokens, security tokens, and staking, farming, marketplace, swap, whatever you can imagine. Even when I was learning this technology, I made a few examples of e-certificate thing, where I can issue certificates on public blockchain, right? So that can be a use case of Ethereum. So issuing a certificate is nothing but just a logic, right? So if it is just a logic, I can write anything. I can make any logic in smart contract, right? We talked about tokens versus coin. What is coin and what is token? Then we saw the live example of we creating our own blockchain, right? Giving the participants entry, right? And anyone updates the transaction, anyone sees, and we can see the request is validated or not. Sorry, the request is validated, if it is a false transaction or not, and many things. Now I would like to open the Q&A sessions. So you can, I see a few questions in the chat. Why does NFT holds any value when the digital art can be downloaded and captured freely? Is it just the ownership of the NFT is worth? Yes. So this is the simple, you say, if you compare it with a simple mechanism, or you say a simple use case, your land, right, is just a piece of paper. I can just Xerox it and change the name. What is authenticating it? It is authenticating the ownership, whom you trust. So in that contract, if I Xerox it, you trust the jurisdiction of India, right? That you did this transaction. This is your ownership of land. It's not mine. If I just Xerox it, no, that's not mine. So in NFT as well, right? If you download it, right, put it in a different manner on a different blockchain, that will not make a sense. If Picasso joins this NFT space, he creates a new painting, right? Let's say named Picasso 2, right? And if he comes in, and we all know that this is the original Picasso, right? And this is the painting which was uploaded by Picasso himself, right? So the ownership of the particular transaction, right, that makes the worth of NFT. It's not about the image, it's about the contract, it's about the transaction, and it's about the trust on the technology itself. Hello, can I get a hello back?
Hello.
Okay.
Hello.
Hello.
All right, we are open for question. When we say peer-to-peer network, how would actually works like a WebSocket connection or HTTP? How node talks to each other? Yeah. So behind the scenes, it's all about you say sockets, right? Where you get data in WebSocket between the nodes, distributed nodes, from where one node is broadcasting the transaction, and everyone is listening for a new transaction, and the miner is obviously chosen randomly. That's a pseudo random algorithm, right? So, but the data transmission and talking of between the nodes, it's obviously done by WebSockets.
Okay, if anyone has questions, then you can start putting them in the chat, or if you just want to unmute your mic and just ask the speaker, then you can do that also.
Sir, can you in brief explain how proof of stake is different from proof of work?
How proof of work is different from proof of stake?
Yes.
Okay. So basically these two are nothing but a consensus algorithm altogether, right? So this comes into picture when you want to agree on something, right? So in proof of work, we talked about that you need to submit the proof that, yeah, I recreated this transaction, right? And I got the data as well as the desired hash, right, with my computation power. And this is the proof which I worked upon, right? So it requires, firstly, it requires a huge computation in it, right? And secondly, you need to be very fast, because if someone submits the proof first, he is the winner and he will get rewarded for it. So this is proof of work, where you need to submit the proof. In proof of stake, what you need to do is you need to have some money staked in, or some financial asset needs to be staked in. Now what happens is pseudo random also gives you to validate it, right? So you stake, let's say you are a part of that particular blockchain, you stake some amount, right? You participate in the you say validators node. Now you are a validator. Now if you validate a valid transaction, the network will reward you, right? But if you do a false transaction, or if you validate a false transaction, you will get penalized, right? Penalizing means the 32, let's talk about Ethereum's POS, right? So if you want to participate in Ethereum's POS, you need to stake 32 ETH. That is equivalent to more than you say, what is the price? It is like 45,000 or what? Sorry, 4,000. Let's talk 4,000. So you need to stake about $128,000, right, in order to just be a mining node. So that's amount which is logged in cannot be you say taken back until and unless you stop validating and stuff like that. Now when you validate the transaction, right, you will obviously get rewarded. You staked your money, you are part of the things, so you will get rewarded whenever you do a good thing for a network. But if you validate a false transaction, right, you will get penalized, in the sense the 32 ETH which you staked in, some amount, the penalizing amount, whatever the network decides, will be deducted from that, right? So POS and POW are in consensus algorithm, but they operate in a different manner. In proof of work, you submit the proof. In proof of stake, you stake more amount. Does it make sense?
Okay, so some work will be done in proof of stake also, but if that work isn't done in time, then that staking would be taken or something like that.
No. Come again.
Some work needs to be done in proof of stake also, no? First to validate and stuff. He will also need to do the work, but if he is unable to do the work, then he needs to give his staking to the main network person.
No, so these two are all separate, you say consensus algorithm, right? So if one network is running on POW, so all the things will be, all the consensus will done on POW only, right? But in case of Ethereum, as of now, you are right, some of the work is done in POW and some of the work is done in POS. That's nothing but a beacon chain. That's the concept of beacon chain, which the Ethereum community is working on. Right? But consensus algorithm stays one only. If it is POW, then it stays POW throughout the network. If it is POS, then it is POS throughout the network. We have question in chat.
Also, one more thing. Say someday I get an idea to make an application out of some blockchain's application. Okay. So should I be using the established blockchain like Ethereum, Solana, and make a project out of that like on DApp, or should I make my own blockchain or something from base and then work on that?
So from what I understand, the network is right. As we talked about trust, right? So if some application is built on top of Ethereum, that has more credibility than some application being made on a fork, right? So it depends on your application if you want to do it, right? If you can leverage the current technology, if you can leverage the current blockchain and just make an application out of it, it saves your time, it saves your money, and it also brings in the trust that, yeah, Ethereum is secured and running from 2012, right? So there is no, you say, in terms of filling out the whole blockchain, but obviously they will look into your application. They will obviously, it's an open source thing, right? So if whatever you upload, right, it gets uploaded to the public blockchain. So the community may see, and if it is look safe, then it goes on. But as I mentioned, the trust for a particular blockchain is one of the biggest factor in terms of your application being growing and sitting ideal.
Okay, so in case like a corporate or government might wish to upload their documents on a blockchain, then they won't be using that public blockchains, and instead they will go for some private one.
Yes, they will go from some private, or maybe they can go for a consortium blockchain where some entities of government entities have the rights to edit or update the data, and some entity have rights to you say read the data.
Yeah, I have a follow-up question to his question only. What if we have to build some decentralized applications? Do we go and build them on for example, on Ethereum? So do we build on Ethereum mainnet or the level 2 scaling applications such as Polygon or furthermore?
So basically, the layer 2 scaling solution as of now in the current market, we see the layer 2 scaling solutions are getting in traction. Why? Because obviously they have less fees that attracts the most, and the second is they have you say high throughput of a particular transaction, right? So that depends on your application, how you want to portray it, right? So if that is something which can be you say used on Ethereum mainnet, right, which has a higher gas fees and low amount of throughput, that's one thing. But if your application is like it has a huge amount of you say data manipulation, I should not say data manipulation, but frequent transaction may happen on your particular application, then I would suggest you to go with a layer 2 scaling solution, because firstly they have high throughput and secondly they have less gas fees. So your users also feel comfortable in order to pay that small gas fee instead of paying a huge $50 gas fee in order to just do a single transaction on your application.
Yeah, but they also compromise on the security, isn't it right? for layer 2?
So if you talk about Polygon, right? So if you know that it's a layer 2 scaling solution, so it has to submit a proof to the master chain, which is Ethereum, right? So it punts the transaction, right, and it submits the proof to the particular what do you say, on the Ethereum mainnet, right? So that is where I was talking that the chain's trust is a major. It takes a major role in order to, if your application, the user is willing to use your application or not, right?
Yeah.
Because some me and some other people also agrees on that Binance Smart Chain is nothing but a centralized chain, and CZ can just demolish all the miners and say that from now the Binance Smart Chain is not running. So because all the 21 miners are from the Binance only, right? So that is where the trust come into the picture. But if you have certain applications which requires high amount of throughput and less gas fees, you should go with scaling solutions. If not, and if you are willing, and if your users are also willing to pay the high gas fees, you can build on any of the master chains like Bitcoin, or sorry, on you say Ethereum or Solana or etc., whichever the blockchain which suits your particular application.
What are these layers that we talk about?
Sorry?
What are these layers that we talk about?
Layers, okay. Layer to scaling solution. So they are basically, you can say it as if I take a simple example of layer to scaling solution, it is your service road. So you have a main highway, right? Or you say not a highway, but let's take a city road, which is very congested and it takes more time. So what you do is you made or a government made the you say sideway or a service road which goes parallelly, right? Works similarly, and it reaches your destination, right, in less number of time. So basically this is your road which is going on. This is a side road or a service road, right? But at the end it merges, right? This is the concept of service road, right? It just allows the traffic to divert, right? Or if we talk about the overbridges are same, right? It just reduces the traffic. Now what if I say in this similar example, if you take this the main road as your the blockchain, which is the main blockchain, Ethereum blockchain, and you make a service road which is similar to your main road, right? And at the end you merge that both. So your transaction gets diverted and it runs on its own, but you obviously submit the proof to your master that okay, this is my proof and I'm not doing anything else. I'm not taking the person in the wrong direction.
It is like VIP line then.
No, it's not a VIP line, but if you want to compare it with, you can, but VIP line is not something which is you say a suitable word to say a layer 2 scaling solution.
No, but then why does Ethereum provide such facility to these layer 2 scaling?
Ethereum doesn't provide such so basically Ethereum doesn't provide this facility of
allows, no?
So layer 2 scaling solutions are made. So whatever I said that you can make decentralized application, right? So layer 2 scaling solutions are also an application made on Ethereum. So it's not that Ethereum is allowing layer 2 scaling solutions to run, but it's also the layer 2 scaling solution is also a program or also a logic which runs on Ethereum blockchain. All right.
All right. Does anyone else have any questions?
How to study further and deeper into this?
So what I'll do is I'll share all my PPTs and all my reference with Jay and the team, and they will pass the information to you guys. All right.
Yeah, sure.
All right.
Okay, now I guess we'll just wait for around 30 seconds or so. You can post your questions if you have in the chat, or you can also unmute your mic, or else we'll end the meeting. And after that, I'll share all the resources, and within a week or so, we'll also post this on our YouTube channel. So if anyone missed any certain part, then you can watch that again.
Sir, one last doubt. How does these tokens or coins get their value? Like,
so
this cost this much, this token will cost this much.
So it's basically dependent on demand and supply, how gold gets its value, right? Because it has less number of supplies, right? We have less number of supplies on our earth of gold, but we have a huge demand that, yeah, we need to purchase gold as an asset or anything else, right? So all the price of tokens or coins are basically dependent on market supply and market. Is my internet bad, guys? Hello?
No, sir.
No, it's not. We can hear you.
Okay, I got an alert. So that's yeah. So it basically depends on market supply and the market demand. What amount of anyone of us are willing to pay for that one particular token or one particular coin.
But that number of tokens could be increased, by the creator of that chain or something.
So once they increase the supply, obviously it matches to the demand and price went down. Right. So if anyone, if you have fixed supply, right, let's say BTC has a fixed supply of 21 millions, right, and there are only 18 million tokens which are out there circulating throughout the market, right? Now I am willing to pay $57,000 to get one BTC, right? But let's say there is some glitch in the network or some glitch in the blockchain of Bitcoin, and the supply drastically increases to, let's say, 1 billion, then obviously the price will fall down because supply is now rising, right? Supply is coming more, so maybe next me can just only give $1,000 for getting a Bitcoin, right? So it's all about supply and demand, what the sellers willing to sell at which price and what buyers are willing to pay to buy a particular asset.
So again, it comes down to trust on that technology or the manager of that technology.
Yes.
Excuse me, sir.
And basically it's not just on the particular person, but you can trust the code. You just not need to trust any person, right? As you write a smart contract, right, you can view that what all functions are there, right, and who all can call that function. So if I say mint, right, then who can mint new things, who can make supply more, right? So at that point in time you can trust the code. You need not to trust any of the person or any of the organization for it. You just need to trust the code.
Okay, got it.
Yes, Ayush.
Sir, is it possible to make our own layer 2 solution and make it scalable?
Yes, you can make it. So you can make something like you. So what I think is layer 2 scaling solutions are just the fork of the Ethereum, right? So you fork it off. Now what you just need to do is you need to maintain two things, which is submitting the proof to the master chain. That's one thing. Second thing, you need to bridge the funds which are being on the Ethereum mainnet to your particular side chain, right? So you just make two things. First, you fork it off. Second, you make a bridge in order to bridge the funds and allow the user to, if they own on the Ethereum, they can still own it on our public block, the side chain. And you obviously need to make a mechanism which says that you submit the proof each and every time a transaction is being done on your side chain.
Sir, so the proof which is to be given is like proof that this project will work and we can make it work independently, right?
No, proof that doesn't mean the project will work. So proof is nothing but a bulk of transaction and it hashes that can be you say compared at any point in time from the master chain, that yeah, this is an valid transaction which we mined and this is not a false transaction which we validated on side chain. Does that make sense, Ayush?
Yes, sir. Thank you.
Yes, ma'am.
Yeah. So how we can bridge a different blockchain, means from Ethereum to Solana or the Polkadot?
So you need to make a bridge for it, right? So if you talk about just the Ethereum, right? So you can make a smart contract which takes care about depositing all the funds in a single treasure, right? And you can submit it. Then you can submit it to your, you say your side chain. So basically, bridge is nothing but it's an code, a logic which keeps the funds locked for a certain period of time on the particular blockchain, right, on XYZ blockchain, and it allows the particular X amount of fund which are locked on this particular blockchain to be minted or to be used on the next blockchain, which is our side chain or any other blockchains.
Okay, yeah.
All right, then. I think we'll just take like one last question, which is in the chat. It says that is there a possibility of cryptocurrencies being less volatile? Why is there so much volatility in the first place?
So that just down to the, you said, trust on a particular thing, right? So let's say tomorrow government comes in and says that yeah, we'll not allow this thing to be running on the in our country, but that doesn't make a sense, right? So if you get a deep dive into blockchain, it's a sensor proof thing, right? Where no country can just say no, will not accept it. No, that's not thing. That's not the thing over here, right? So volatility depends on many of the factors, not just the trust, but it depends on the particular network, or you say particular, what do you say? What's the best word which I can portray it? You say liquidation in the market, right? How much people are willing to pay, right? And there might be some, you say, trading logics behind the scenes where some people may see that this is the best price to sell and they sell it down, and the volatility. So volatility itself is a big word, right? It can have n numbers of factors, not just the trust, not just the news, not just the power outage which went on China, not just being Satoshi Nakamoto coming into the picture and saying that I own the whole Bitcoin network. It can be anything. It can be a single news tweeted by Elon Musk to being in the news channel that Bitcoin is going, I mean, the all private currencies are going to be, you say,
banned,
being invalid on the particular country.
All right, yeah. So it's mostly about, it's because of a lot of reasons, including the technology itself and the people who are involved in doing the transactions, because volatility isn't something that's based on one thing, and that's why we have so much of it.
Yeah.
And also, so if you can just share your LinkedIn or any particular handle through which the students can.
Just give me a
because
second.
I think, yeah, because I think a lot of folks really want to have a conversation with you after the event if they face any issues.
So you can just scan this QR code, and this leads to my LinkedIn profile. We can connect through LinkedIn.
All right. Yeah, so everyone whoever posted the question, the others who like that particular chat, you can just scan the code and that will take you to his LinkedIn profile. So that's it. Thank you so much, sir, for coming. We know you are busy working with a lot of different aspects. So thank you for taking the time and addressing the students who are really interested into blockchain and also entertaining quite a lot number of questions. Thanks for answering them. We really hope that we have you in the future as well with us, because I think blockchain is something that a lot of people here are interested in. So thank you so much for that. Yeah, and if you have anything else to just mention to the students.